In the Beginning by Dr. Walt Brown. We're going to continue here on page 131. Jigsaw fit of the continents. For centuries, beginning possibly with Francis Bacon in 1620, many have noticed the approximate jigsaw fit of the continents bordering the Atlantic. It is only natural that bold thinkers such as Alfred Wegener in 1915 would propose that the continents were once connected, as shown in figure 54, and somehow they broke apart and moved to their present positions. But would continents, including their broad but submerged continental shelves, really fit together as shown in textbooks? Distances are distorted when a globe is flattened into a two-dimensional map. Therefore, to answer this question, I formed two plates on a globe matching the true shape and curvature of the continents. The classic fit, figure 54, proposed by Sir Edwin Bullard, appears at first glance to be a better fit of the continents than my plates. However, notice in figure 54's description the great latitude Bullard took in juggling continents. Were these distortions made to improve the fit? Few, if any, textbooks inform us of these distortions. Okay, that's figure. Let's go see what he's looking at. Oh, here's that is figure 54 over here. Okay, and then he made figure 55. Okay, got it. Okay, zooming back in. Few, if any, textbooks inform us of these distortions. Instead of fitting the continents to each other, notice in figure 56 how well they each fit the base of the mid-Atlantic ridge. The hydroplate theory proposes that these continents were once in the approximate position shown in figure 56. Right here, I believe. No, this one. That's instead of touching the continents, just line it up with the mid-oceanic ridge. Okay. Yeah. And let it erode a bit, and you got what you have now. Okay, they were connected by rock that was rapidly eroded and transported worldwide by erupting subterranean water. As these eroded sediments were deposited, they trapped and buried plants and animals. The sediments became today's sedimentary rock, and buried organisms became fossils. The continents quickly slid on a layer of water, rapid continental drift, away from the rising mid-Atlantic ridge and toward the subsiding Pacific floor. They came to rest near their present locations. Details and evidence will be given later in this chapter. Layered fossils. Fossils rarely form today because dead plants and animals decay before they are buried in enough sediments to preserve their shapes. Nor do we see fossils forming in layered strata that can be traced over thousands of square miles. How then did so many fossils form? It will soon become apparent why animals and plants were trapped and buried in tens of millions of cubic miles of sediments that were quickly cemented to form the fossil record, and why fossils of sea life are found on every major mountain range. Okay. Changing tilt of Earth's axis. George F. Dodwell served as the government astronomer for South Australia from 1909 to 1952. In the mid-1930s, he became interested in past changes in the tilt of the Earth's axis. He collected almost 100 astronomical measurements made over a 4,000-year period. These measurements show that the tilt of the Earth's axis smoothly decayed from 25 degrees and 10 minutes to its present value of 23 degrees and 27 minutes. Based on the shape of the decay curve, Dodwell estimated that this axis shift began recently. Oh boy. Began recently. The gravitational forces of the sun, moon, and planets do change the tilt of the Earth's axis, but much more slowly than the changes Dodwell measured. An extraterrestrial body striking the Earth would provide an abrupt change in axis orientation, not the smooth changes Dodwell measured. Also, only a massive and fast asteroid striking the Earth in a favorable angle would tilt the axis that much. However, the resulting pressure pulse would pass through the entire atmosphere and quickly kill most air-breathing animals, a recent extinction without evidence. Comets and meteorites. These strange bodies, sometimes called the mavericks of the solar system, have several remarkable similarities with planet Earth. They contain considerable water. About 38% of the mass of Comet Tempel 1 is frozen water. Water is rare in the universe, but both common and concentrated on Earth, often called the water planet. Most of the remaining mass of Comet is dust, primarily the crystalline mineral olivine. Solid material that formed in space would not be crystalline. Olivine may be the most abundant of the more than 2,500 known minerals in Earth's crust and mantle. Asteroids and meteorites are similar in many ways to Earth rocks. Surprisingly, a few meteorites contain salt crystals, liquid water, and living bacteria. Some asteroids have a chemical substance, kerogen, found in plants. Earth's radioactivity. Few people realize that the origin of Earth's radioactivity and the heavier chemical elements have never been explained. Furthermore, radiometric dating assumes that radioactive decay rates have always been constant. A careful understanding of the flood will show how and why Earth acquired its heaviest chemical elements and radioactive materials, and why the constant rate assumption, and therefore radiometric dating, is grossly in error. This understanding will show how, 1, just how powerful the fountains of the Great Deep were, and 2, how the flood destroyed the Earth in ways that are still being felt. Summary. These are a few of the mysteries associated with the 25 topics listed on page 121. The hydroplate theory will explain these mysteries and tie together the cause and effects of the dramatic global catastrophe. This is Walt Brown's In the Beginning, Ending Up the Mysteries.